everyone. Welcome to Orchestration Heat Templates webinar. Today's speaker, Mauricio Tavares, is a Linux and Network Systems Administrator at the Renaissance Computing Institute at the University of North Carolina at Chapel Hill. He is currently involved with Chameleon Cloud and Enter, enabling network research and the evolution of a next-generation mid-scale research infrastructure. In previous webinars, we saw how to create and run an experiment using Jupyter Notebooks and automate configuring an experiment in multiple servers inside a custom network using Ansible. This time, we will raise the bar once again and use a heat template to create the entire experiment. Reservation, servers, network, experiment, without human intervention besides starting the build process. You will leave this webinar knowing what a heat template is, how to write one, and how to set up a reservation in the future that will automatically create your experiment from scratch at the reserved time. The webinar will last about 45 minutes with time for questions at the end. During the presentation, please type general questions in the Q&A box. Members of the Chameleon team are on the webinar and will be answering your questions. Thank you, and welcome, Mauricio.
Thank you. First of all, if you have questions after the webinar, send your questions to help@chameleoncloud.org. And if you don't have a Chameleon account, please go to this link and create an account, and then raise your hand, and then we're going to assign you to this project. So let me get out of here. Okay. So today we're going to be talking about using heat templates to configure Chameleon instance. If you don't see on your Jupyter lab the Chameleon document here, go to GitHub, Chameleon Cloud, and hit Notebooks tutorial getting started. And then you should see it here on Heat Orchestration. You really don't need to use the Jupyter Notebook. This is just here as documentation. Everything we're going to be doing, we're going to be relying, every action we're going to be doing is going to be relying on the heat template and the Chameleon Cloud web interface. So why we're going to be using heat templates? As it was said in the introduction, when we started using Jupyter, when you start using Chameleon Cloud, you can use the web interface here, and then you can select make a reservation, create your network, and then create your instance. That is time consuming. The next step we did, we went to Jupyter, and then we created a test lab by following this Jupyter document and then clicking on each step and having it run to do that specific step. That's an improvement because that's repeatable, but that's still slow. The next step we did in another document, we used Ansible. But that Ansible presentation, we had part of it being done on the Jupyter and part then done on Ansible. Now, by using the heat template, we are going to see if you can eliminate as much of the human interaction as possible, so to cut down your time, so you have more time to do your experiment. So heat template is really a glorified YAML file. In fact, let me show you the one we're going to be using here. And it's divided into different sections. Description, you can imagine what it is. The parameters are actually variables and constants that we're going to be asking the user to enter on the startup, but we can have default values, such as default, or for instance, if you're selecting an image, we can say that, okay, we want to, if the user doesn't enter one, we're going to use this CentOS 7 image. And the default flavor, bare metal, the default name of the network, my network, very original, I know. Now, when but the general format of the heat template is we're going to define variables and constants as like those parameters that can be input or modified by the user. Then we are going to define some actions, which we call the resources. These actions are very similar to what we did here. Oops. If you go back to the original Jupyter Notebook, those actions are creating a lease, reserving an IP address, creating a network, attaching the SSH key we're going to use to this lease, and off we go. So if you look here, this step here, we are actually creating the network, which is called private network. And the name is a parameter, which is a variable that's called private network name, which is input here. If the user doesn't enter it, by default, it's going to be called my network. Then here, we are creating the subnet associated to this network. And we are setting up to do DHCP. The network ID is just related to, it is derived, as we know, from the private network. We could have defined the gateway IP. I chose not to because this is a small experiment. And it's using the default IP assigned to the gateway. This is the gateway. So what it does here, we're telling it that, it goes outside the public network. We are not defining here the public network because this is already defined within Chameleon. So other interesting things here. This is a server. And this server, I'm going to be later on assigning an external IP so we can SSH into this server. That's why I called it EXT server. And some properties it's picking up from both the parameters that we enter on when we start running the template, and also this resource here, which is defined on the beginning of here. Now, the fact that this resource defined here, that means that this server can only be created after the resources it depends on, or resource and attributes depends on, are already defined. In this case, I'm going to be adding the IP address of the two other servers we're going to be creating to its etc. hosts. That means that the server has to wait for these other two servers to be created, get on a private IP for it to ask. Until that happens, this server cannot be created. So everything from here on, layout for this experiment, we used it before when we did the presentation Ansible. I don't have a good drawing now, but actually I do. Let's go. There. Yeah. Okay, it's a small diagram. But use the external server, and that's how you're going to connect to it. And then we have a server here that we're going to be running the experiment. Or it's going to be running a program called iPerf. And this other server is going to be connecting to this one to do a performance test of the network. And it's going to store the results on itself. And then we can get the data by any means we want. For instance, we can SSH to this guy, then SSH to here, and then get the data. If this was a better experiment, we could probably automate that once this guy creates the output, it automatically sends to this one. So we can collect the data out without ever logging into these two guys. Once again, that's the magic about automating everything. If this experiment doesn't require user interaction, we should not interact with it. Let the experiment do its own thing. So, okay, these are the two servers that we talked about. The iPerf server, which, as you see, it's using the same key, the same SSH key, the same image, which you define as CentOS, and the same flavor, which by default bare metal. There is nothing stopping us from making this completely different, like saying instead of being CentOS can be Ubuntu or whatever. We just have to define it somewhere. I would rather not define it here if I can get away with, so we can customize it later. Now, this server, once it builds up, it's going to run this little series of commands, which first going to install Git, it's going to install the development meta package for CentOS, download the Git file, and build iPerf, and then it's going to run iPerf into server mode. And that's how it's going to be doing. Notice that the only thing it requires are variables that are defined when we start running the program. When you start running this template, and then after that, the private network. So, but now the client kind of does the same thing. Yes, I should have just decided if I want bash or Bourne shell, but it's okay, we'll survive. Downloads, compiles, installs. The reason it compiles and installs is because we are going to be running iPerf from inside it, and we are going to connect the server running the iPerf already, and you're going to save the output to this file here. Since it needs to know the iPerf server IP, it has to wait for the other server to be built so it can get its IP address and then connect to it. This thing output is just that, if you want, you can ask it to spit out some information about anything you did here. In this case, I'm just saying like iPerf, all the private IPs of the 3 servers. I probably won't even bother with this, honestly. So yes, we have this. If you go through the HIT orchestration document, I actually going to be going through some examples of those configuration commands. But we're really, That's pretty much what we saw by just looking at the YAML document, the heat template. So you can come back and refer to this. For us to run this, we are going to go to, we need a reservation. We could have created the reservation automatically and call the heat template at the assigned time. For right now, I won't be doing that because I want to use the web interface to show each step how it works. So I created a list already. I'm going to go here to orchestration stack, launch a stack. The template, as you see, can be a file, direct output, so I just cut and paste, or I can just put somewhere that I can give a URL, and then it can fetch it. I'm going to pick as a file because I already have it on my computer. And that's the same iPerf document. Now we're going to hit next, we wait. Now, it wants a name for the stack. Or for the, okay. Okay. This, it needs a password because it's going to be running some commands under your user. So it's going to need your password here. Now, if you see here, flavor name, and you come back here, where's flavor name? There's flavor name. And you see, it's looking for a string. The label here is called flavor name, here. And the default is bare metal. I'm going to just leave it bare metal. The image name, as you saw, the default CentOS 7. I'm lazy, I'm going to use that. The subnet, that's good enough. Key pair, I'm going to use this key. It's very important, you know, if you're going to run this, two things you need to have before you start to run the heat template. You need to have your key associated, I'm going to cancel that. Your key already defined here in Chameleon. And in my case, I have all those keys here. And I probably want to be using this key because I like it. And as I said before, you need to have a list defined if you're using the web interface. So let's go back to what I was doing. Orchestration, stack, launch, file, iPerf. Okay. Okay, good, good, good. As I said, I'm going to use instancy. It's a good name as any for the network. You don't like it, change it. And you see that's the name of my reservation, my list that I had defined. And then we're going to launch it. We wait. So what's happening here is going to create a network. After it creates the network, subnet, assign the IPs, the floating IP. See, it already picked up a floating IP and created my network. Created my router. Yes, the very original name, router. If you don't like it, you can come here and change the name or make it so you, the user, can change the name here, the router, to something more special. And Now we are going to go to the computing nodes. Remember what I said before, it's starting the iPerf server first, because of the 3 servers, it's the only one that doesn't rely on the other servers. So we would have to wait for these servers to build. And after that, then the iPerf client will be started. And then after that, the external server is going to be started. For this experiment, it's okay because the iPerf server is the one that's going to be running the iPerf nonstop. The iPerf client, once it starts, is going to connect to it and then do the test and save the data. And by the time that is done, the iPerf, the server we can use to connect to here is still will not have finished starting. So we're good. Now, let's see what else we can do. I think, we're going just to wait for this one to finish and then the other one to start, because I already have them all done. And in fact, it's kind of boring because the experiment, it runs automatically. But if you have questions, this is a good time to ask. Also, while we're looking to that, just to let you know, the code I use here to create the network, if you want to see an example just with that by itself, if you go to the OpenStack appliance, which you can just be like Chameleon Cloud, not OpenStack, but the Chameleon Cloud appliances. And if you scroll down here, I know I have a link that goes straight to it, but okay, should be, did I miss it? Must have missed it. Maybe it's here. There it is. It's this one here. You could just, as I did, just click here and get to this guy. And if you get here, you can hit get template. And then it's going to save the template to your machine, and then you can do some editing. Or we can go, that would work. That's pretty much the template. If you run it, it does the same thing. It creates a router, creates a subnet, creates a network. The order here is not really important because, as you saw, whatever depends on something else is going to wait for that something else to be created. And then it outputs, or actually not outputs, just the input. As you see, it really doesn't matter if you put on the beginning of the end. It will find where the parameters are. I personally like to put on the beginning, but here's in the end. And you see it's very similar to what I was doing. In fact, that's why I stole this. So let's see how our guy is doing. Okay. As I said, I just want to see the other one to start to show that they are starting sequence, and then we can ignore them. So okay, we're going to oh yes. Sometimes when you create your templates, you might want to define which version you're going to use. And the reason is because later templates might have added features that may not be available. So if you go, the link is here, but if you go to orchestration, template versions, those are all the templates that are known by the Chameleon Cloud. And then you can go click on that and see which functions are available and things like that. And then you can build around that. So for instance, if you, let's see what, as you can see, the version 2018 has much more interesting stuff. So anyway, that's if you want to do some fancy stuff, that's where you should look. And then once you find the template that has what you want, and it's listed here on the template versions, then you specifically ask for it. Now, okay, I think feels like we already installed enough. Go back to instance, and you see, as I said, the server has started. Now it's creating the client, it's just spawning it. So because it needed to know the private IP address of the IPserve server after for it to run its scripts. So it's a requirement. But we are going to now start cheating. And you're going to go to my already defined. So once this is done, you're going to have one iPerf server, one iPerf client, the ext server, which has an externally accessible IP. And we're going to, then we can use it to SSH and then access those guys. One thing I'm going to do here while we're here, yes, we can SSH, but also, actually might as well SSH, -I. 192.168.2. No, it's 87.162. Okay, something went interesting. But we also have the shells here. That's why it was having problems. When this machine started, it did not get an IP. Like this guy here, you see this guy has an IP. And that's a server. Let me move this up a little bit. And you see it's still running iPerf 3 happily. and listening on port 5201. Actually, let me copy this guy. Okay. Okay. And I think it was 5201. Yep, 5201. Doesn't say much because it doesn't know how to, because the protocol, but that's a result file. And this is how it looks. And in fact, we can run it again here. Is iperf3, I don't remember the command. Okay, -c. I'm just running the same command that, you know, the script, the template already ran to compare the results. But yes, I can run it manually, but why should I run it manually when I have a perfect good script that can run it, put in a file, and then I can use, I'm going to reboot this server to see if I get an IP. Because sometimes that's a way to force it to get an IP. Even though it was a last machine. But so anyway, we have the file here, then we can copy it by any means necessary. And really, you could just go do this here and be done because it's a small file. Or we can put in a port that the other guy can get, or we can do SCP, or we can copy to a Git repo, or we can SCP from here to somewhere else, some external storage. So we really don't need this guy to get the data out. It just depends any way you want to do it. So that is, okay. This is a physical server, so yes, it's going to take some time. Now let's see how the other one we start in this class is doing. You see it's still building the other machine, the client. And because of the dependency on the, here, the dependence on attributes and parameters, attributes and resources, each machine has to wait until they can access those resources and attributes they are depending on before they continue. Now, what else? It's why this guy is running. If you think that you have seen this format before, the reason is that this format is pretty much based on the AWS documentation. I'm going to click from here so it opens a new window or not. But the style for the structure is very similar to AWS did on CloudFormation. So, okay, we use that. Don't need that today. So, as I said, those are the appliances. There is some documentation. If you scroll down here, the there was a blog. Okay, that's going to take a bit of time. Here, as I said, on the Jupyter Notebook, there's nothing here to run unless you want to click on some reference here. In fact, it's already the result here, what you should see. How you're getting out of here, it's up to you. There are some, for the previous labs that we showed how to use on this case, this server as a jump point to this. So you don't have to log into here and then log into here. And you can also have this server just go ever so often, retrieve the output from here, or this server go and push the output when it's ready, or push the output somewhere else. That's up to you. And other important thing here is, I'm not going to do for this guy, but if you want to, okay, you see now it's active. So we're probably going to see very shortly, see, the external server now is going to be created because its requirements have been satisfied, its dependencies have been fulfilled, so now it can be created. Once you're done, here, if you want to delete this entire thing, you can just select your stack and go here and say delete stack. I'm going to do it right now. And what this does is going to delete the networks, it's going to delete the instance, release the public IP, and everything else in between. As soon as this finishes, I'm going to show it in action. All right, as soon as this wobbly thing finishes, we can show that in action. Out of curiosity, how many of you logged into Chameleon, went to Notebooks, Tutorials, Getting Started, and saw the HIT orchestration file here? If you see the HIT orchestration file, you go inside the folder orchestration and you're going to see this HIT template there, iperf.yml. Should also be here. If you can't see it, you go to chameleoncloud.org, or no, github.org, github.com, Chameleon Cloud, Notebooks, Tutorials, Getting Started. Yes, it looks very familiar. And there it is, HIT orchestration. And if you go inside here, there's iperf. And if you want to use it, oh, this guy's still doing his thing. You can, okay. You can save this to your computer, or you can hit, for instance, raw file here, cut this, go to here. When you create your launch stack, you remember you have the option just to paste the entire thing, and you can do that and be done. So many different ways to push your HIT template into Chameleon. I was going also to talk about how to do that from command line. And I have to say that I didn't put it in the documentation. So you're going to have to wait for me to update this document, but it's going to be available here and on GitHub. And here's some more information about OpenStack, more information about how to what the HIT templates are, how to well, how to install it, don't care much about that, but creating your first stack. The template is important, and examples are very useful. And then you have some useful guidelines or things like that. And also, Chameleon Cloud has their own documentation about how to use heat templates. And they use them to do their so-called complex appliances. All those appliances are considered complex because sometimes you're building a, like this guy here, has more than one server or network being created at the same time. So, like this guy here. So it's more convenient to do that using GitHub, not GitHub, but Heat template. And really, if you're giving a class or something like that, you should start your experiment maybe using a Heat template so it's ready for you and you're not wasting time. And then you can have your students use a Jupyter or whatever to do their lab assignment. And final thing is that just because you use the Heat template to do a lot of automation, which is in this case, I run pretty much the entire lab. You know, I created everything, ran the experiment, and the experiment is done. There's nothing stopping you from using this to build your lab experiment for the kind of experiment that you need to do some interaction. Because all you have to do is, for instance, I'm going to use a quick example here. Let's say you're going to use, you want this guy to run iPerf or something else. You can just compile it, install it, get it ready, and then wait for you then to go to another machine and then run your experiment and try change something else and run and things like that. Just like we did here. You see, I already run the experiment, but I can run it again. I can change, you know, I can take a look and see all the other arguments I can give to iPerf and just run it again. So, you know, yes, I'm using the console here, but there are other ways. As you know, there are other ways you can access this machine. And we could even, instead of doing this entire script thing here, we could have just download the Ansible playbook, run the Ansible playbook, and be done. So many different ways to build things here. This is the basic of the basic way to build it for an experiment that you have, you know, multiple machines and your own network. So I think we're kind of running out of time. So I think that's pretty much it. Let's see how this guy's doing. You know, okay. Let me just restart. Yeah, we can ignore it. See, now deleting progress. That's what I wanted to show. Okay, if you go here on floating IP, it's gone. Router, it's going to be deleting shortly. And then once it deletes the router, then it's going to delete the network. And let's see how's the instance doing. You see it's already deleting one. And then it's going to delete all the others in order and everything else. The bottom line here is, just like we use Heat template to create your experiment. Okay. I can delete it manually. Yeah, sometimes things break. You just have to fix it or go work around. But the idea is we should be able to use the Heat template to create the experiment, and then you run the experiment, and then you can use it to tell it delete everything. Because you need all the time you can to do your experiment, not to be building machines and networks and things like that. not the infrastructure of your lab. Okay, any questions?
All right. Well, Mauricio, thank you so much for your presentation today. We really appreciate your time and that of our attendees. Thank you all and have a wonderful rest of the day.